Today I want to talk about an amazing little device called a ferrite bead. I recently had a problem with my shack and I had energy going where it shouldn't go, and the solution was to add ferrite beads. I want to cover a little bit about the basics of ferrite beads, maybe a little bit of detail, and explain how to use them and why the beads that you maybe already own are not the appropriate ones. So typically, a ferrite bead looks like this. It's just looks like a little magnet that is the diameter of your wire, and you clip it on, and that is supposed to add a degree of impedance to the circuit so that you don't get back current. So what does that mean? Let's take a look at a little diagram here. The DC current is moving from your power supply to your radio. You can see there's a ferrite choke on there. The AC current coming from your radio is supposed to go up through your antenna, but can find other routes, including your power supply. So the most common place you want to put a ferrite choke would be from the power supply to the radio, and you want to place the bead as close to the radio as possible. Now, typically when we're dealing with HF, for my purposes, 10 and 11 meters, even 12 meters, just clipping a single ferrite bead on is not going to cut it, but the bead you choose does matter. And so there are times, if you're using the right bead, that fewer is better. But typically, people are misusing these beads by just clipping them onto a diameter of wire and either assuming it worked or not noticing much difference. And there's a reason for that. The typical way we would use a ferrite bead would be to add a number of turns to the cable that goes through the bead. So what we have here is a multiple turn. You would select a diameter of bead that is roughly 3 times wider than your cable and wrap the cable twice through, even 3 times through, and that gives you a much more substantial inductance. This is an exponential gain, so whatever the base inductance is for the particular ferrite that you're using, the second turn is 4 times more inductance. And if you wrap it a third time around, I believe it's 9 times the inductance. And so there's this exponential gain per turn, which means you can quickly overdo this and counter what you were trying to do. And let's talk about composition of these beads. If you go on Amazon, you're going to find, if you type in RF choke or ferrite bead, you're going to get probably a mix number 61 bead show up. There are lots and lots and lots of 61 beads on Amazon, and these are not appropriate for our purposes. Those are for VHF and higher. And if you're having the same problems that I'm describing here for VHF, those are fine. But I'm dealing with like 10 meters, 11 meters, and that's where my issue was. So what I really need, ideally, is a mix 31. Now what the mix is the composition of the ferrite core. Mix 31 and 43 are both manganese zinc, but the ratio of the two metals is different for each of those mix types. We want mix 31 for HF. Mix 43 can work, it just, you can't go too high with it. You can also use these on antennas, but it depends on what kind of antenna you have. A very common practice is to wrap a 6 to 8 inch coil of coax to make a choke up near the base of your antenna. And if your antenna is a ground plane antenna, that will work just fine. If the antenna is not a ground plane antenna, that's going to basically make your antenna not function correctly. So if you're going to buy beads because you've heard of scenarios like this, the biggest mistake people make is buying the wrong beads. But these are great. Just understand how they work, and now you're the expert.